All right, the next section we're going to deal with is piecewise functions. First, review what was done last section, evaluating functions. In this first example here, f of a negative 4, because we are dealing with the f function, we are going to have to substitute a negative 4 in for x, which putting it here doesn't do anything. That's just telling you what you're evaluating at. So on this side, you have to substitute a negative 4 for x. Well, there isn't one. So our answer is just 3, because there's no place to put it, so it's always going to be 3. Next question down, what is g of a negative 4? Well, here is the g function. We need to substitute a negative 4 for x. So we have 1/2 times a negative 4 plus 4. And a half of a negative 4 is a negative 2 plus 4, and that is going to equal 2. Now then, if we have f composition g of a negative 4, all right, so we know we have to do that part first, and g of a negative 4 we have figured out is 2. And then f of 2 is going to equal, well, if we put a 2 in here, again, there's no place to put the 2, so it's going to be 3 as our answer. Doing the other one, g f of a negative 4, or g composition f of a negative 4. First, we have to find out what is f of a negative 4. Well, f of a negative 4 is equal to 3. And so now we're trying to figure out what is g of 3. And 1/2 times 3 plus 4. Half of 3 is 1.5 plus 4 is 4.5. And if you have something along this line, it's f plus g of a negative 4. Well, here you have to figure out what's f of 4, or negative 4, and what's g of a negative 4. Well, we know f of a negative 4 is 3, g of a negative 4 is 2, and so f plus would be 3 plus 2, or 5. If you had f divided by g of a negative 4, well, then you would have 3 divided by 2, which is 1.5. So that's a review of the last section. Now we're going to get into piecewise functions. And they look like this, which, if you notice, these two things are exactly like the two functions we dealt with before. It's a combination of a couple of different functions. Sometimes it can be even more than 2 pieces. It could be 3 or 4 or 5. Now, in this piecewise function, this part of it is what you use to evaluate. This part of it is the domain of that part. So first you have to look at this part to determine which part does it fit into, and then you evaluate the function using the thing in blue. So here we have f of a negative 2. We are going to evaluate it at a negative 2. So now we have to come over to these things. And does a negative 2 fit here or there? Negative 3 is less than a negative 2, which is less than 2, or 2 is less than a negative 2, which is less than infinity. Well, 2 does not fit in between, or negative 2 does not fit in between 2 and infinity. It does fit in between a negative 3 and a positive 2. So this is the one we need to use. And so now we have to evaluate when 3. Substitute a negative 2 in for x. Well, there's nothing to substitute in for. So this answer is just 3. Moving on to the next one. F of 2. All right, so same thing. check here. Does a negative 3 fit into 2? Or does 2 fit into here or there? Well, is the negative 3 less than 2, which is less than or equal to 2? Well, that part right there is true. Here it's 2 is less than 2. That is not true, so it doesn't fit here. It fits here again. And again, 2 gets substituted for x. Well, there is no x, so this answer is just 3 as well. Moving on to our last one here, f of 4. Well, if 4 is here and 4 is there, is a negative 3 less than 4? Yes. Is 4 less than or equal to 2? No. Does not fit that one. Is 2 less than 4? Yes. And is 4 less than infinity? Yes, it is. So, therefore, we are going to use this particular function. And so we have 1/2 times 4 plus 4. Half of 4 is 2, plus 4 is 6. So for this function f of 4 is 6. Now I suppose if they asked a question like what's f of a negative 5, well, if you put a negative 5 here, negative 3 is less than a negative 5. That's not true. And if you put a negative 5 there, 2 is less than a negative 5. That's not true either. So this one would have no answer. Okay, so that's how you evaluate a function. First, you have to use this part to determine which piece of the function you're going to use. Once you figure out which interval it fits in, you come over to the actual function and evaluate it by substituting in for the variable. Now, if you were going to graph a function that is a piecewise function, just do the same thing. Graph each part separately. So first, let's start with that. That's what we need to graph. That's like saying y equals 3, which is a horizontal line at 3. So you draw it first. But it says we only need the part from a negative 3 to a positive 2. Well, negative 3, 1, 2, negative 3 is right there. And a positive 2 is right there. And so we have to get rid of all the rest of it. And then because it says a negative 3 is less than x, there would be an open circle here at a negative 3. And x is less than or equal to a positive 2, so there's a closed circle on 2. Then for this part of it, 1/2 x plus 4. So that tells us we cross the y-axis at 4, and our slope is 1/2. And I'm going to come down here, and here's the line that is drawn. But we only need the part from 2 to infinity. Well, here's 2 again. So we need to erase this, get rid of this part. And then, because it is 2, it's got to be an open circle here. And then it goes off to infinity in that direction. And so that is what the graph looks like. As another example, here we have a negative 1/2 x plus 2 from a negative infinity to a negative 1, 5 from a negative 1 to 4, and 2x minus 3 from 4 to infinity. So first to draw a negative 1/2 x plus 2. Crosses at 2, slope is a negative 1/2. And I'm not going to draw the whole thing because I don't need the whole thing. I only need the part from a negative 1 to a negative infinity. And it is x is less than or equal to a negative 1. So a closed circle here at a negative 1, and the line is going like this, and continues on forever. And this part we don't need. Then we have our graph being at 5, which is up here, 1, 2, 3, 4, 5, and it goes from a negative 1 to a positive 4. But at a negative 1, it's just less than, or greater than, so it's an open circle, all the way over to a positive 4, where it is a closed circle. And then finally, 2x minus 3, which negative 3 is right there, and the slope is up 2 over 1. And then we have to go from 4 to infinity. Well, 4 is right here, so we need an open circle. Let's redo that part. This is a closed circle for the orange part. Well, now there's an open circle here, and then it's going up and to the right. And so this has an open and a closed circle at this point. What that means is it doesn't matter what value you put in. It just so happens that if you put a 4 here, it's going to be 8 minus 3, which is 5, which is what you get here if you put a 4 in. But you're supposed to use, if you were trying to evaluate f of 4, you should use this function to figure that out. But that can happen where you have an open circle on top of a closed circle, and therefore it's a function. It can't be a closed circle on top of a closed circle, because then it's not a function. And that is everything for this particular section, so you'll be getting a worksheet on this.